Okay, so this is the Edexcel paper 1 that was in 2025. So I've typed up all the questions and I thought we could go over the questions that did come up in that paper 1. So let's jump right into it. So the first question says, find the highest common factor of 54 and 120. So you could have listed all the factors and then up until you got the highest amount. But what you can do is you can do the prime factor trees for each of these and then use a Venn diagram. So that's what I'm going to do. So we've got 54 and then 120. Two numbers at times to give us 54. Well, it's even, so 2 times 27. Yeah, because half of 50 is 25. And then half 4 is 2. Okay, so that's a prime number, circle that. Two numbers at times to give us 27. That's just a 9 and 3. 3 is a prime number. Two numbers at times to give us 9 is 3 times 3. Okay, let's do 120. We can say 2 and 60. That's a prime number. Can half it again. 2 times 30 and 3 times 10. 3 is a prime number. 10 is just 2 and 5. Okay, so drawing the Venn diagram now. Let's do 2 circles. This one being 54, this one for 120. So for 54, so first let's do the numbers that are in both of them. So in both of them, I'll do this in a different color. So we've got 2 in both of them, so I can put that here. I have got a 3 in both. And that's it. There's nothing else that's the same because I've got 3s here and I've got 2 here. So I've got a 3, 3. Then I've got 2, 2, 5. So for the highest common factor, what we do is we just times the middle 2 numbers. If I was finding the lowest common multiple, I times all the numbers together. So for the highest common factor, I'm just doing 2 times 3, which is just 6. So the highest common factor of 54 and 120 is just 6. Okay, question 2. We've got a probability question. There are only red counters, white counters, so red, white, and blue counters and green counters in a bag. So that's in the table here. Chris is going to take at random a counter from the bag. The table shows the probability that he'll take a red counter and the probability he'll take a white counter. So that's already filled in. It says there are twice as many blue counters as there are green counters. So to evaluate that as a ratio, I could say, so if there's twice as many blue counters as there are green counters, I could say green is X and therefore blue, because it's twice the amount, is just 2X. Okay, work out the probability that Chris will take a blue counter. So we just need to fill in the table, I guess. So the total of these 4 probabilities will be 1. So 0.3 plus 0.1 plus these 2 here. So blue being 2X and then green being X. The total of this will equal 1. 0.3 add 0.1 is 0.4 plus 2X add X is 3X. That equals 1. Let's get X by itself. So I'm going to minus 0.4. So I get 0.6. And then X equals 0.6 divided by 3 is just 0.2. So X is 0.2. X is green, which is 0.2. We don't want green, we want blue. Where blue is 2X, so 2 times X, which is 2 times 0.2. That's 0.4. So I'll just write that here. Probability of getting a blue counter is 0.4. And you can always check your answer. These 4 numbers here should add up to give you 1. And we know we've got twice as many blue counters, so it should be double the probability of green. 0.3 add 0.1 is 0.4. Add 0.4, 0.8. Add 0.2 is 1. So confident that's my answer. Okay, part B. There are 45 red counters in the bag. Work out the total number of counters in the bag. Okay, so the amount of red counters in the bag is essentially 30% because it's 0.3 the chance of getting a red. So we could say 30% is 45 red counters. So if I find 100%, then I've essentially got the total number of counters. So just to reiterate, 30% of all the counters is red because we've got 0.3 being the probability of getting red. So if I find 100%, that's the total number of counters that's in the bag. So since this is a non-calculator paper, I'm just going to divide by 3 each side to get that to 10%. So 45 divided by 3, 3's into 4, 1, carry 1, 3's into 15 is 5, so 15 is 10%. And then to get that to 100%, I'm going to times by 10. So I times this side by 10, so 150 counters is the total number of counters. It's 150. Okay, so that's question 2. Moving on, let's go on to question 3. So it says here, complete the table of values for this equation here. We've got y equals x squared plus x minus 4. You should have an idea what that graph looks like. It's a U-shaped graph because it's got a positive x squared. If it was minus x squared, it'd be n-shaped. So we know it's a U-shaped graph. So when we're sketching it, we should get something that looks like that. So complete the values. All we need to do is we just need to substitute the value of x into the equation to get y. So let's do this 0 first. 0 squared is 0, add 0 is 0, and then minus 4, so 0 minus 4. Let's do 1. 1 squared, add 1 minus 4. So 1 squared is 1, 1 add 1 is 2, 2 minus 4 is minus 2. And then we've got, let's do 2. We've got 2 squared, which is 4. 4 plus 2 is 6. 6 minus 4 is just 2. Let's do the minus 2 now. We've got minus 2 squared, which is 4. And then plus minus 2, which is minus 2. 4 minus 2 is 2. Then 2 minus 4 again gives us minus 2. Okay, so that's our values. I would recommend just double checking that, but hopefully it'll follow the U-shaped curve for the next part of the question. So on the grid, draw the graph of the values between minus 3 and 2. So we're just plotting all these points up here. We've got minus 3, 2, which is here, minus 2 over here, minus 1 minus 4. We've got 0 minus 4. We've got 1 minus 2, and then 2, 2. So it looks like a U-shaped graph. Now remember, had you joined up this like a dot to dot, you would have lost marks. You have to draw a smooth curve joining them all up together. So maybe a bit tricky to do on a tablet, but let's try. So we're going to do a smooth curve going through all points. That's why it's really important to take a pencil into the exam just in case you just want to try again. Okay, so there you go. As expected, it's a U-shaped graph. All the points look to be corresponding on there, so I'm pretty confident that my answer is right for that table of values as well. Okay, perfect. Part C, it says write down the coordinates of the turning point of the graph, so and so. It's only 1 mark, so you don't really need to complete the square. What they want you to do is they want you to read it off the graph. And if we have a look, we can see the turning point is this part here. So it's in between, it's right there in the middle. They just want you to read it off. That's why it's 1 mark. However, if you did use completing the square, you'd still get the right answer and you'd be fine. But we can see in between minus 1 and 0, you can see the y values are staying the same. So in between minus 1 and 0 is minus 0.5. So that would be for our x value, minus 0.5. And to find the y, you could just read it off, to be fair. But to be quite accurate with it, you could substitute minus 0.5 into the equation for x, and then you'll find out what y is. So I will just do that now. I'm going to use a calculator just to save time. So minus 0.5 squared plus minus 0.5, which is minus 0.5, minus 4. That gives me minus 4.25. Minus 4.25. But I'm pretty sure for the y value on the mark scheme when it does officially come out, I reckon they'll give you a range of values. They won't just accept only minus 4.25 because they'll know a lot of people are just reading it from the graph with it being 1 mark. So that seems sensible. Minus 4.25 is probably roughly around there as well. Okay, so that was for 1 mark, and that's question 3. Let's move over to question 4. Okay, we've got 5-mark ratio question. So there are 280 chocolates in a box. I'm going to write down information as I'm doing this as well. So in the box, we've got 280 chocolates. That's our total. There are only dark chocolates, milk chocolates, and white chocolates. So throughout, I'm just going to write D, M, and W just for times. 1/7 of the 280 chocolates are dark chocolates. So I can work out dark chocolates. 1 out of 7 of 280 is 280 divided by 7. 28 divided by 7 is 4, and then add a 0 on it. Okay, so we know there's 40 dark chocolates. Okay, perfect. So I know there's 40 dark chocolates in that box. Okay, that's fine. The number of milk chocolates to the number of white chocolates is 1 to 3. Okay, so milks to white is 1 to 3. And the number of white chocolates to dark chocolates is n to 1. So it's a lot better just seeing it like that. It says work out the value of n. So n being the white chocolate ratio to dark chocolates. So we know the number of dark chocolates in the box. We've just worked out 40 dark chocolates. So therefore, we know the remaining amount of chocolates in the box. We can do 280 minus 40 chocolates, and that's going to be the number of milk and white chocolates. So 280 minus 40, there's 240 milk and white chocolates because there's only dark milk and white. So if we know dark is 40 because we worked out 1/7 of 280 that they've told us is dark chocolates, the remaining is milk and white. So we've got the number of milk and white. So we've got a ratio for milk and white here. So we know 4 parts altogether, so 1 plus 3 is 4 parts, is 240 chocolates because milk and white is what this ratio is. So knowing 4 parts is 240, I can work out what is 1 part. I'm going to divide by 4. So I'm going to divide this side by 4. 240 divided by 4 is just 60. So 1 part is 60. So we know the number of milk chocolates now. So I'm going to just write here. So dark is 40. We know milk is 1 part times 60. So it's 60 chocolates for milk. And then for white, it's 3 times 1 part. We need 3 parts for white. So we're timesing by 3. So therefore, I'm going to times this by 3. 60 times 3, well, 6 times 3 is 18, and then add a 0. So 180 are white chocolates. And you can just double check, do all them add up to 280 to make sure you got it right. So 40 add 60 is 100. 100 add 180 does give you 280. So we've worked that out right. We know how much of each chocolate there are now. So we can go over to this ratio here with the unknown n. Just budge this up a little bit. Okay, so working with this one now, we know the number of dark chocolates in here are 40, and we know the number of white is 180. So we know that's the ratio using this here. So what we need to do is, how do we get from 40 to 1? Well, we divide by 40. So whatever you do to one side, you do to the other side. So we're going to do 180 divided by 40 to find n. So n equals 180 divided by 40. Cancel the zeros. 18 divided by 4, I can say 9 over 2. So n is just 9 over 2. Or you could say 4.5. You'd still get the answer for that. And that's how you do that question for 5 marks. I think what you had to realize was for this question, we do not know the number of white chocolates here, so unknown. So we had to use that other ratio somehow. So that's part A for 5 marks, 9 over 2. Or you could write 4.5. You'll still get the marks for that. Part B. It says 10 milk chocolates from the box are eaten. So milk chocolates. Does this affect your answer to part A? Give a reason for your answer. Well, what did we work out in part A? We worked out the value of n. What is n? N is the number of white chocolates. And the ratio we were working with was white chocolates to dark chocolates. So all you would just say, no, as n is the number of white chocolates. So had white chocolates or dark chocolates been taken from the box, then it would have affected your answer because we use this ratio here. As n is the number of white chocolates, and then you could just say we used ratio W to D to work out n. So you could just say D. You could just say milk chocolates does not affect this. Milk chocolates removed does not affect this. Okay, so that's question 4. Let's move on. Let's do question 5. Got a standard form one here. Work out, it's 5.7 times 10 to the power 2. So they were quite cheeky to not add brackets there. But that's something in standard form and something in standard form here. Now the times 10 to the power part is different for each, the 10 to the power 2 and 10 to the power 3. So we can't just do 5.7 and 9.8. What I would recommend is just change them to numbers. 5.7 times 10 to the power 2 is just, well, that 5, the decimal point is going 2 upwards. So it's just 570 for that. Yeah, so 5.7 times 10 to the power 2, we're putting the 5 up 2 times, and therefore the 7 moves up 2 times with it, and then a 0. Okay, the 9.8 times 10, so we're adding that to 9.8 times 10 to the 3. This 9 is moving 3 up. The 8 is going to move with it, so therefore we've got 2 zeros after it. So we're doing 9,800, add 570, 0, 7, 8, add 5, 13, carry the 1, 10. They want our answer in standard form. So remember, in standard form, we can only have a number between 1 and 10. So to change this number, I'm going to say 1.037 times 10. Well, imagine the decimal point was here. How much times does it move to get to up to here? It's 1, 2, 3, 4. So it's times 10 to the power of 4. And that's my answer for 3 marks. So yeah, there was other ways you could have done this question as well. So not necessarily, it didn't have to be that way. That was a good 3 marker. Okay, question 6. A, B, B, C, C, D, and D are 4 sides of a regular polygon. Regular meaning that all sides and angles are going to be exactly the same with n sides. So we don't know how much sides this is. So we can see here's a polygon. It's basically going to continue around, but we don't know how much sides it is. They've shown us part of it. Well, 4 sides of it. BCX is an equilateral triangle. So BCX, that's an equilateral triangle. What do we know about equilateral triangle? Same sides, same angles. There's 180 degrees in a triangle. So therefore, if you divide that by 3, because all the angles are the same, each angle is 60. So I can put that in. And it says CDYX is a square. So here's a square. And in a square, I know all the sides are the same. And I know that they're all right angles. So I can put that in as well. Okay, it says work out the value of n. What is n? N is the number of sides. You must show all your working. So we need to find one of the interior angles. Now, I'm guessing we're using this triangle and square. Since we know this is 60 and we know that's 90, we can work out one of the interior angles there. That is an interior angle if I add 60 and 90. So I could just say the interior angle is 90 plus 60, which is 150. And now using our equation, so n minus 2 times 180 over the number of sides, and that's going to equal our interior angle. So this is just one of the equations that you need to know. So just to reiterate this top part here, n minus 2 times 180, we then divide that by the number of sides, and that's the value of one interior angle, which is 150. And this is what we're solving to find n. So I'm going to times n up to here. So I get 180 n minus 2 equals 150 n. 180 n minus 360 equals 150 n minus 150 n to the other side. So I get 30 n. And I'm going to plus 360 to the right hand side. So n equals 360 divided by 30. Cancel the zeros. 36 divided by 3 is 12. Yeah. So therefore, n is 12. So it's a 12-sided shape. Okay, so that's question 6 for 4 marks. I'll just leave that there. Let's move on to question 7. Okay, so we've got an algebraic fraction that we're simplifying. Simplify, I'm going to write out here, 3 times 2 minus m squared. Remember, 2 minus m squared is 2 minus m times 2 minus m. Over 2 minus m, which I could put a bracket around. You can see that this cancels with one of these. So we're just left with 3 times 2 minus m. Simplifying that, 3 times 2 is 6. 3 times m is minus 3m. So that's our answer. So we've just simplified it. Okay, we've got an inequality now. Solve 7 plus x is less than or equal to 5x over 2 minus 8. So solve just basically means find x. It said simplify in the last question. So we need to get all x's to one side. Let me get rid of this number first. I'm going to plus 8 over to the other side. So I get x plus 7 plus 8 gives me 15. That's less than or equal to 5x over 2. Let's times the 2 up. So we get 2 times x plus 15 is less than to equal to 5x. Expanding this, we get 2x plus 30 is less than or equal to 5x. We need to bring all the x's to one side, and I want to keep x's positive, so I'm going to bring this 2x to the right-hand side. So I get 30 is less than or equal to 5x minus 2x, which is 3x. I need to get rid of that 3, so I'm going to divide by 3. 30 divided by 3 is 10. We really want our x first, so let's make that a bit smaller. Okay, this is saying 10 is less than or equal to x. Well, I could just swap the signs. I can say x, big side is near the x, is more than or equal to 10. So they both say the same thing, but you should always have your x first. So x is more than or equal to 10. And that's our answer for 3 marks. Okay, part C, it says solve this, so we're finding y. So since it's in the middle, whatever I'm doing to the middle, I need to do to both sides. So I'm going to get rid of that 4 first. So I need a minus 4 from both sides. So I get 5 is less than 2y, which is less than, well, sorry, 2y is more than 5 because 9 minus 4 is 5. And then 12 minus 4 is 8. I need to get rid of that 2. So I need to divide by 2, both sides. 5 divided by 2, I'll just leave like that. Or you could write 2.5. 8 divided by 2 is 4. And that's my answer. Okay, so that's all question 7. Just leave that there. Okay, moving on. Question 8. Okay, ABC is a right angle triangle, which I can see here. So ABC, so ABC is just that. That's a right angle triangle. Cool. AEC and ADB are straight lines. So AEC and ADB, so it's saying them two are straight lines. Okay. ED is parallel to CB, which I can see with arrow. These two are parallel to each other. Prove that triangle ABC is similar to triangle ADE. So ABC, which is the big one, ADE is a small one here. So I'm just going to draw out both triangles. It'll make it easier to prove. So let's draw a smaller one. So the bigger one is A, and then C is here, and then that's B. The smaller one is this one over here. which is A, E, D. Well, we know on the big one, this is a right angle. And because lines ED and CB are parallel with each other, we can also assume this is a right angle here. So that's a right angle there. Okay. And both triangles are sharing this angle up here. So angle A is exactly the same on both of them because both triangles share them. You should really be writing some words with this as well. So I'm just saying it so I don't have to write it down. Okay. And angles in a triangle add up to 180. So if these two are going to be the same that we've just proved, then this third one has to be the same because angles in a triangle add up to 180. So I've just proved angle, angle, angle. So both triangles are similar. So everything that I just said, you should be writing that down as well. But just because I want to get through this video quite quick, I'm just going to leave it at that. Okay, part B. It says ED is 20, which is on the diagram. CB is 30, that's here. And AC is 18. Okay. Work out the length of EC. So EC is this part here. So work out that length here. Okay, so I'm guessing it's to do with, because we've got two similar triangles, we can use scale factors. So I'm going to work out the scale factor. Now, I'm going to draw on these two triangles up here for this question. But obviously write it down again, but I'm just going to write it here. So I know on ED that's 20, and I know this is 30. So to work out the scale factor, I can just do 30 divided by 20. Cancel the zeros out. So 3 divided by 2, so it's just 1.5. We'll leave it as is. So if the scale factor is 1.5, and I know on the big shape this is 18, I can work out this triangle here, so that and that is the same length. Then I can just minus them from each other to find EC. So to work out AE, I'm doing 18 divided by the scale factor, which is 3 over 2. So how can we do that? I could say that's 18 over 1 times, flip the second one over, 2 over 3. 18 times 2 is 36 over 3. 36 divided by 3 is 12. Okay, so this is 12 here. So if I know all of it is 18 and I know this little part is 12, then I can work out EC. I'm just doing 18 minus 12. And that just gives me 6. So EC is just 6 centimeters. And that's question 8. Let's move over to question 9. So this question here says, describe fully the single transformation that maps shape A onto shape B. So how do I go from this shape over here to shape B? Okay, so it's quite hard to describe this just using the tablet, but what you would need to do is use tracing paper. And using tracing paper, you'll realize that this is a rotation 90 degrees anti-clockwise. Anti-clockwise. And you have to also work out the center of where that rotation happens from. So on your tracing paper, you would draw that, you would have turned your tracing paper, realize it's anti-clockwise 90 degrees. But to work out that center, you'd have to use a compass and draw some perpendicular bisectors to figure it out. I can't do that on the tablet right now to figure out what is actually the center. So unfortunately, I can't answer that part of the question. But it is rotation 90 degrees anti-clockwise. Okay, let's do part B. Should be able to do this on the tablet with it being an enlargement. So it says enlarge the triangle by scale factor a half. So because it's a fraction scale factor, I'm expecting my new triangle to be smaller than this one. And center 1 minus 3. So where is minus 1, minus 3? Sorry, minus 1, minus 3 is here. So what I need to do is I need to figure out how do I get, choose one of the points in the triangle, and how do I get to minus 1, minus 3? So I'm going to just count on here. So I'm going 1, 2, 3, 4, 5. Oops. Let me choose a point first. I'm going to choose this point here since it's closest. I'll do it in red. Okay. So 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6 up. So 4 to the right and 6 up. Now, because I'm doing scale factor a half, I just need a half them amounts. So I'm going to move 2 to the right, and I'm going to move 3 up from here. So I'm going to do that again. But this time I'm going 2 to the right from my point. So minus 1, minus 3. I'm going to go 2 to the right, 1, 2, and I'm going to go 3 up. 1, 2, 3. So right there. Okay. And I know that I don't have to do that with every single point. I know if I'm going to go scale factor half, everything's going to half. So since that's 4 here, I know it's only going to be 2. So it's just going to be 1, 2. Same for this. This is 1, 2, 3, 4. I'm going to half that. It's only going to go 2 upwards. And then I can just join these together with the triangle. And that's my answer. So that's that's question 9. Let's move over to question 10. What proof question? Prove that the difference in the squares of two, so in the squares, difference is minus in the squares of two consecutive even numbers is always a multiple of 4. So we're doing the difference, two consecutive even numbers. Our first one is going to be 2n. Our second one is 2n plus 2. So because I'm doing the difference, I need to minus these from each other. So I'm going to minus the bigger one from the smaller one. 2n plus 2, and then 2n. And because I'm doing the squares, I have to put a square around both of them, and I'm minusing them. Okay, so let's expand and see what we get. So this one, we get 2n plus 2 times 2n plus 2 minus 2n times 2n. 2n times 2n is 4n squared. 2n times 2 is 4n. 2 times 2n is 4n. And 2 times 2 is 4. Minus 2n times 2n is 4n squared. Simplifying this, they cancel out. We've got 4n and 4n is 8n, and then plus 4. Now, what does the question say? Prove that it's always a multiple of 4. So I need to factorize 4 out. 4 times something gives me 8n, that's 2n. 4 times 2n is 8n, plus 1. So there you go. We've proved that it's a multiple of 4 because we factorized it out. So that's for 3 marks, question 10. Let's move over to question 11. We've got here t is inversely proportional to w, so I'm going to write that here. T is inversely proportional to w, so it's 1 over w. W is directly proportional to the cube root of d, so it's directly proportional, it's not 1 over. Okay. It says when w equals 6, t equals 20, so that's for this case because we've got a w and t here. And it says here when w equals 1, d equals 8, so that's for this question here. It says work out the value of d when t equals 48. Now, before we do this, we need to change both of these equations to something in terms of k. So we've got t equals k over w, and this one we've got w equals k times the cube root of d. Now we need to find k in both of these instances. We need to find the constant. So I'm going to substitute each of the conditions they've given us. So when w equals 6, t equals 20. So 20 equals k over 6. So I've just substituted 6 and 20 in. To find k, I'm just going to times by 6. 20 times 6, well, 2 times 6 is 12, so 120. Okay, so we found k. So I can substitute back into the equation. So I'm going to do it in red. I've got t equals 120 over w. Let's do this one now. When w equals 1, we've got k times the cube root of 8. So the cube root of 8 is 2, so we could just say 2k. To get k by itself, I'm going to divide 2 to the other side, so I get a half. So I can plug that into the equation above. I get w equals k, which is a half, times d cubed. Okay, so we've got both equations and we've found k as well. So now what we need to do is find the value of d when t equals 48. But d is in this equation here, but it's not in terms of d, it's in terms of w. So we need to find w to find d, and that's why we're going to use this equation here. I'll just use a different color. Let's use blue. So when t equals 48, so 48 equals 120 over w. So let's find w. I'm going to switch these two around. So I'm going to times by w and divide by 48. So I get w equals 120 over 48. I can simplify that. I can half the top and bottom. 60 over 24, half again, 30 over 12. I can divide by 3 top and bottom. 10 over 6. Not 10 over 6, sorry. I just, let me half them actually, they're even. 15 over 6. Divide by 3, 5 over 2. Okay, so w equals 5 over 2. I'm now going to substitute w into here. 5 over 2 equals a half times d cubed. So I'm going to divide by a half first. I want to get d by itself. So 5 over 2 divided by a half. Let me do it over here. Divided by a half equals, well, that's 5 over 2 times, flip the second one, 2 over 1. I just did keep, change, flip. 10 over 2, which is just 5. So 5 equals the cube root of d. Now, to get d by itself, the opposite of cube root is cubing. So I'm doing d equals 5 cubed. And 5 cubed, 5 times 5 is 25. 25 times 5 is 125. And that's my answer. So that's how you get 5 marks in that question. Okay, moving on, let's do question 12. So this one might be a tricky one to do because I've just drawn the graph myself, so it might not be exactly the same as it was in the exam, but it is more or less similar-ish. So I'm going to tell you the method more so than the actual answer that matters. So the graph shows the velocity of a particle t seconds after it starts to move. So it's a velocity time graph. And there's two important things you need to know about a velocity time graph. The gradient is acceleration, and the area under the curve is the distance traveled. So that's the two most important facts you need to know about velocity time graphs. This is not the same for a distance time graph. It says work out an estimate of the gradient of the graph at t equals 3. So t equals 3 is, I'll do it in a different color. T equals 3 is right here. Now what you had to do is you had to draw a tangent at that point. So it's a bit hard to do without a ruler, but like so. So you had to draw a tangent, find 2 points on that line, the tangent, and just work out the gradient. So, or you could have drawn a triangle actually. So I could just say gradient is change in y divided by change in x. All I needed to do was find 2 points on there to do it. Now it's quite tricky to do it on here, just because this graph might not be exactly what was in the exam. But I'm choosing a coordinate here. I can say 450 there on the line. I could also choose maybe this one here, which is 230. So I'm going to do the change in y. So I'm going to do 50 minus 30 over the change in x, which is 4 minus 2. I'm expecting a positive answer because it's positive gradient. So if you got negative, that's completely wrong. 50 minus 30 is 20 over 4 minus 2, 2. So just 10, I guess. So that's an estimate of the gradient, so 10. But I'm pretty sure they would accept like a range of answers for this one. But yeah, I've got 10 for that one. Let's do the next question. It says, what does this gradient represent? Remember, gradient is acceleration, but give it in the context of the question. So acceleration of, what is it of? A particle. So of a particle. Okay. Part B says, work out an estimate for the distance the particle traveled in the first 6 seconds. The questions has even said as well, use three strips of equal width. So they've given you kind of the answer. They're helping you do it by saying that. So you should know that distance is area under the graph, which we've just said up here. So we need to split this into 3 equal strips. Now, since there's 6 seconds, 3 equal strips of that, I'm going to do this in red as well. So 6 divided by 3 is 2. So I'm going to do strips of 2, so like so. So what they want you to do is find, let me do this with straight line. 1, 2, 3. So they're my straight lines. Okay, and I'm finding the area of each of them, essentially. Now with this first one here, so I'll just call them A, B, and C, so you can see how I'm working out here. So for A, I can see it's a triangle with 2 on the bottom, so a half times 2, and then the height is 30 times 30. So 2 times 30, 60 times a half is just 30 for that first part. Part B, I can split it into a rectangle and another triangle, just like that. So for the rectangle, I can say between 2 and 4, that is, for this base here, that's 2 times the height of this rectangle is 30. And we're adding that to the triangle area. So again, it's a half times the base of that is 2 times the height of that triangle. We can estimate that to be 20 again. Really, if you want to be really accurate, it is roughly around here, but I'm just going to say 20. Yeah, 30, 10, 20. So I'm just going to say 20. Working that out, 2 times 30 is 60. 20 times 2 is 40. 40 times a half is 20. So we get 80 for strip B. Let's do strip C now. Again, I'm going to split into a triangle and a rectangle. So for the rectangle between 4 and 6, that's 2 as the base times the height, which is 50 of that rectangle. Adding that to the area of the triangle, so a half times the base is 2 and the height is 10. So that just equals 2 times 50, which is 100. Add 2 times 10, 20. Half of 20 is 10, so we get 110. So we're just adding A, B, and C. So we're doing 30, add 80, add 110. 110, add, well, 80, add 30 is 110, add 110. 220. Okay, so that's an estimate for the distance, and I'll just say meters because the speed is in meters per second, so therefore the distance is meters. So that's question 12. Okay, let's move over to question 13. Okay, so we've got given some recurring numbers and it says work out the value of x, y. Give your answer as a fraction in its simplest form. So we need to change these recurring numbers to fractions. So I'm going to do x equals 0.2222. So I need to times it by 10 to bring a 2 up. And I'm going to minus these from each other. So I'm going to bring this up to the top. A lot of people get confused and they say, how do you know to times by 10, times by 100, or so on? I need my recurring numbers after the decimal to always be lined up. And since it's just one number repeating, just 2, I just need to bring one number up. So I'm minusing these from each other. I get 9x equals 2 minus 0 is 2, and then these cancel. So x just equals 2 over 9. I can't simplify that. So I've got x equals 2 over 9. Let's work out y now. So y equals 0.8681. It's the 81 only recurring. So it's just this. So this 6 is an issue for me. I need to bring this 6 up. So I'm going to times it by 10 first. So we get 6.81, 0.8181, so on. So this is good now because after the recurring number, I've just got only the recurring number. The 6 is not interfering. Now I need another number to minus it from, but I need the recurring number to be the same. So I can't just times this by 10 again because only the 8 will come up and then the 1 will come up and it just messes up the pattern. So I need to times it by 100 from here to bring up two numbers up. So I get 10y times 100 is 1000y equals 681.81.8, not 0.81, sorry, 8181. The 81 recurs, so you can see the recurring number is exactly the same. So I'm happy with that. So now I'm going to minus these from each other. Let me just write it out again. So 1000y equals 681.8181 minus 10y, which is 6.8181, continuing forever. So you can see my recurring numbers are lining up. So when I minus, they'll cancel. 1000y minus 10y is 990y equals 681 minus 6 is 675, and they cancel. Okay. So therefore, to get y by itself, I'm just going to divide by 990. Okay, so I've rewrote my x and y's in terms of fractions, and now I'm just timesing them. So I'm doing x times y. X times y is 2/9 times 675 over 990. Now, what you could have done is you could have simplified this and then times them, to be fair. So I'm going to do that actually. Before plugging y in, I'm going to simplify this. So I can divide the top and bottom by 5. So 675 divided by 5, just use your long Bush-Shelter method. I'm just going to quickly use a calculator to save time. 990 divided by 5 gives me 198. Now, the top number and the bottom number, so 135 goes in the 3 times tables. The reason why I know that is 1 add 3 add 5 is 4, 9. And 9 is in the 3 times tables. And the bottom, 1 add 9 add 8 is 18, which is also in the 3 times table. So I can divide the top and bottom by 3. 135 divided by 3, use your bus stop method, 45. 198 divided by 3 gives me 66. I can divide by 3 again. 45 divided by 3 is 15. 66 divided by 3 is 22. Okay, so 15 over 22. Okay, let me just double check that is right before continuing. Okay. Yeah, okay, so we're timesing these together. So 2 times 15, so a lot easier to do now, is 30. 9 times 22, use your long multiplication method, that's 198. I can divide the top and bottom by 3, so I get 10 over 198 divided by 3 is 66. I can divide by 2 top and bottom. I get 5 over 33. And that's my final answer for 5 marks. There was a few different ways you could do that in terms of simplifying. So I'd say the hardest thing with this was yeah, timesing and dividing would have just taken time for this question, which is why it's 5 marks. So that's question 13, 5 out of 33. We'll move over to question 14 now. Okay, question 14. So there are 9 balls labeled 1 to 9 in a box. So I'm just going to write it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're the balls are in the box, okay? Lee will take at random 2 balls from the box. Okay, 2 balls he's going to take. He says that the probability that the sum of the numbers, so sum of the numbers will be an even number, is greater than the probability that the product of the numbers, so sum means add, product means times, will be an even number. Is Lee correct? You must show how you get your answer. So we need to work out some probabilities. So we need to work out the probability of the sum of the numbers on the two balls will be an even number. So probability that the sum, how could I write that down? I'll just write sum of balls, it's fine. So probability that the sum of the balls, and we need to find the so is an even number. Could put that inside the probability actually. It's a better way I can write this. So probability that sum of balls is even. And I need to work out the probability of the product of the balls. So there's two numbers, there's two balls that are going to be chosen, is even. So I need to work out each of these probability, and if this, so the sum is greater than that, then Lee is right. However, if it's not, then he's wrong. So we need to think of these numbers here. How can we make an even number? Now, there's so many different ways you can make an even number. So what I'm going to do is I'm going to split these numbers up. I'm going to make a pile of odd numbers. So 1, 3, 5, 7, 9. 1, 2, 3, 4, 5. Okay, so they're my odd numbers. And I'm going to make a pile of even numbers. So 2, 4, 6, 8. So I've got 4 even numbers and I have 5 odd numbers. Now, if I add these two balls together, so if I do odd add even, I would always recommend just trying a few different things and see what happens. If I'm doing odd add even, so for example, 1 add 2, that gives me 3. So odd and even gives me odd. If I okay, let's start off with the product one first. That might be a bit easier too. I feel like there's a lot of different case scenarios with the sum one. So let's start off with the product one first. If I times two odd numbers together, so if I get odd, odd, okay, so if I get odd and odd, let's try two numbers, what happens? I get like, I don't know, 1 times 3, that's going to stay 3. So therefore, try another one. If I do 1 times 9, that's 9. If I do 3 times 9, that's 27. So yeah, odd times odd will always give me odd. Okay, if I do even times even, 2 times 4 is 8, so that's going to give me even. 2 times 6 is 12. 8 times 6 is 48, so I'll always get an even number. What if I do odd and even? So if I do odd times even, if I do 3 times 2, for example, I get 6, so that's even. If I do 1 times 8, that's 8, so I'll always get an even. But I can also do it the other way around as well. I could get an even the first time I pick a ball and then odd the second time, and that will also give me an even. So you can see there's 3, that's the only possibilities I could have: odd, odd, even, even, odd, even, or even, odd. Now you can see there's 3 different times I can get an even number, so I'll have to work out 3 separate probabilities and then add them all up together. Instead of doing that, I could just work out this one up here, and then I can do 1 minus that, because the probability altogether has to add up to 1. So if I find out what's the probability of getting odd, odd, and then minus it from 1, that's the probability that the product of all the balls will be even. So that's what I'm going to do here. There's loads of different ways to do this, but that's what I'm going to decide to do. I'm going to do 1 minus the probability of getting odd, odd. Now, what is the probability of getting odd, odd? Well, the first probability, we've got 5 odd numbers out of a total of 9 balls. We're going to times that by the probability of getting the second one odd. Well, we've taken 1 odd out, so now we've only got 4 odd remaining, and our total number of balls is 8. So 5 times 4 is 20 over 9 times 8, which is 72. But remember we're doing 1 minus that. So 1 minus 20 over 72. I can change that 1 to 72 over 72 minus 20 over 72. 72 minus 20 is just 52 over 72. Okay, so this is a probability that the product of the balls is going to be even. Now let's do the sum and see what happens with the sum. Okay. If I have an odd plus an odd, so because I can choose an odd and then an odd, let's try a few numbers. If I have 1 add 3, that's 4. Okay. 7 add 9, that's 16. So it looks like odd plus odd will give me even. Okay. If I get even, add even. So if I get even, 2 add 4 is 6. Okay, that's even. 6 add 4 is 10. So yeah, it gives me even. So I'm just trying out a few numbers, see what happens. What if I get odd and then even? So if I have an odd number, 5 add 4, 9, that's odd. Let's try another one. 9 plus 2 gives me 11, so yeah, it gives me odd. And then even plus odd would also be the same. That would also give me odd as well. So we need that the sum of the balls is even, which is these two options here. Okay, so alternatively, you could work out them two and then minus it from 1 just to keep up the same. But I can just work out these two probabilities here to work out the sum of the balls being even. So let's do odd odd first. So I'm going to do the probability of odd odd, and I'm going to add it to the probability of even even, and that'll give me the probability of the sum of the balls being even. Okay, so the probability of it being odd odd, well, we've already worked it out. That's 20 over 72. We've worked it out here. And we need the probability of it being even even. So even, well, there's 4 even balls out of a total of 9 times the second one being even. There's 3 now because we've taken 1 even out, and the total is now 8. 4 times 3 is 12. 9 times 8 is 72. So if I add them two together, that gives us 32 over 72. So the probability that the sum of the balls is going to be even is 32 out of 72. And 32 out of 72 is less than 52 out of 72, but Lee said that it'll be greater, this probability. He's wrong. So you're just going to say Lee is wrong. And reason why, probability of the sum is 32 out of 72, which is less than the probability of the product, which is 52 out of 72. So you would write a little bit more than what I have, but that's how you do it. So that was quite a strange question to put in the GCSE exam, but they wanted you to list out possibilities, odds and evens, and just put in some numbers and see what happens. Let's move over to question 15. We've got a histogram here. So the histogram gives information about the weights in grams of some biscuits. So we've got frequency density on the y-axis, and we've got weight on the x. Now remember, frequency density equals frequency divided by class width. So if I wanted to work out frequency to go backwards, I'm going to times the frequency density by class width. So just keep that in mind, that equation. It says one of these biscuits is taken at random. Work out an estimate for the probability that the biscuit will have a weight between 20 and 40 grams. So we essentially need to work out the frequency of how many biscuits there are. So between 20 and 40 grams. So here's 20 grams. I will use a red pen. Here's 20 grams here. And 40 grams is half, not half, 2/3 of that actually. That's there. So we need to work out the frequency of this whole section here. This is what we need to work out the frequency of. So we're going to go backwards. Let's work out how many there are all together for each of these. So working out the frequency of each bar without the red. So this first one here, I'll do it in blue. We've got 10 as a class width, and well, we're working out frequency. So we need the frequency density and we're timesing it by the class width. So we've got 3 times 10, which is 30 for that first one. Let's do the next one. We've got between 10 and 30, so I'm doing the whole thing, not just the red. Between 10 and 30, the class width is 30 minus 10, which is 20. So we're doing 20 times, that's 5 here. 20 times 5, it's right here. So 2 times 5 is 10, to add a 0, 100. So there's 100 between there. Now between 30 and, that's 45 actually. So 45 minus, so I'm working out the class width, 45 minus 30, 15 between that class width, and 15 times 8, so 15 times 8 gives me 120 for that whole bar frequency. And then the final one, we've got 15 again. 15 times 10 is 150 for this one here. So adding them all up together, so the total 30 plus 100 plus 120 plus 150 gives me 130, add 120, add 150, that gives me 400. That's the total amount of biscuits we've got all together. We need to work out how many biscuits in this red part here. Now, you can see this red part here for this first one, it's exactly half. Let me do this in red. So this part here is half of 100, which is just 50, because it's exactly half of that bar, so that's 50. And this red bar here, we can see it's 2/3. So you can see 1, 2, 3 bars, and 2 of the bars are colored of that. So it's this bar here, the red one, is 2/3 of 120. So if I do 120 divided by 3 times 2, that gives me 80. So the red bars together are 80 plus 50, which gives me 130. So remember, this is the red bars colored. 400 is the total. So therefore, to work out the probability the biscuit will have a weight between 20 and 40 grams, the number of biscuits between that is 130 over the total, which is 400. Let's simplify that, cancel a 0, I get 13 out of 40. So that's my answer for question 15 for 4 marks. Moving on, let's do question 16. Okay, we've got some surds here. It says here, rationalize the denominator, give your answer in its simplest form. So to rationalize the denominator, so 35 over root 7, I'm going to times by root 7 over root 7 to get rid of that surd on the bottom. So on the top, I get 35 root 7 over root 7 times root 7 is just 7. 35 divided by 7 is just 5, so I get 5 root 7. For 2 marks, that's the top one. Now here we've got root 27 minus 1 over 2 minus root 3 can be written in this form. Work out the value of a and b. So I need to rationalize the denominator again. So I'm going to put brackets here. To rationalize the denominator here, I'm going to times by what's on the bottom, but change the sign. So 2 plus root 3 over 2 plus root 3. Yep, and let's times it out. Root 27 times 2 is 2 root 27. Root 27 times root 3, which is just like this, right? So root 27 times root 3, 27 times 3, use your long multiplication, but I'm just going to do it in here. It's root 81, which just gives me 9. Okay, so that's 9. And then we've got minus 1 times 2 is minus 2. Minus 1 times root 3 is minus root 3. Okay, over 2 times 2 is 4. 2 times root 3 is 2 root 3. Minus root 3 times 2 is minus 2 root 3. Minus root 3 times plus times positive root 3, but that's minus 3. The surd cancels out. Let's simplify. Hopefully the surds disappear on the bottom. We've got 2 root 27 on top, and then we've got 9 minus 2, so 7, and then minus root 3, over 4 minus 3, that's 1, and then 2 root 3 minus 2 root 3, they cancel out, that's gone. If I'm just dividing by 1, I'm left with 2 root 27 plus 7 minus root 3. But they want it in this form here. So surely I should be able to break that root 27 down into something times 3. Well, I know 9 times 3 is 27. So I can break root 27 down into root 9 times root 3. And root 9 is just 3. So root 27 is 3 root 3. And 2 times 3 root 3, so I'm changing that for 3 root 3. 2 times 3 root 3 is 6 root 3. Add 7 minus root 3. Simplifying that, our A is 7, and then 6 root 3 minus root 3, there's a 1 in front of that, so it's 5 root 3. So we can just say A is 7, and B is 5. So that's our answer for question 16, a 4 marks and a 2 mark question. Now let's move over to the final question, question 17. Everyone was quite shocked that there was only 17 questions. I don't think we've had a paper like this before. They usually tend to be over 20 and less 5 markers, I guess. Okay, so it's a functions question and a composite functions one. We've got g of x and h of x. It says show that this has one solution for x. So we need to find each of these. So let's find, I'm going to find hg of x first. That one's a bit easier. So we're finding h of g of x. G of x is 1 minus 3x. So substituting this into h of x, I get 2 times 1 minus 3x squared minus 1, which is 2 times 1 minus 3x times 1 minus 3x minus 1. Let me just double check I've done that right. H g of x, substituting g of x into h, plugging that in. Okay, let's expand. 2 times, I'm going to ignore that 2 for now. 1 times 1 is 1. 1 times minus 3x is minus 3x, and minus 3x times 1 is minus 3x, so we get minus 6x. Minus 3x times minus 3x is plus 9x squared minus 1. Expanding this out, 2 times minus 6 is minus 12x. 2 times 9x squared is 18x squared minus 1. Simplifying that, I'm going to put the x squared first. 18x squared minus 12x, and then 2 minus 1 is just 1. Okay, so I found hg of x. Let me make that a bit smaller. So I found this. Let me find 3g h of x now. I'll do it in a different color. Okay, so 3 times g h of x. So ignoring that 3 for now, we've got g of h of x, where h of x is 2x squared minus 1. So I'm plugging that, I'm going to leave the 3, I'm going to completely ignore that 3 altogether, and I'll just plug it right in at the end. Makes it a bit easier to do. Okay, so I'm plugging this in to g of x, which is 1 minus 3 times x, which we've said is 2x squared minus 1. Okay, let's simplify that. We get, I'll do it here, 1 minus 3 times 2x squared is minus 6x squared. Minus 3 times minus 1 is plus 3. Keep it over here to line it up. We've got minus 6x squared, and then 1 add 3 is just 4. So therefore, 3gh of x, I'm just timesing this by 3. So 3 times minus 6x squared plus 4 is minus 18x² plus 12. Okay, so we're adding them to all 3gh of x, which is minus 18x² plus 12. Add hg of x, which is this here, plus 18x² minus 12x plus 1. And we're equaling it to 0 and we're solving. Because we're showing that it's just got just one solution for x. So let's solve this. Minus 18x² plus 18x², that cancels. So we've got minus 12x. And then 12 add 1 is 13. That equals 0. Let's make x positive. I'll bring it over to the right-hand side, so I get 13 equals 12x. Now, to get x by itself, I'm going to divide by 12, so I get 13 over 12. So there, I've just proved that it only has one solution for x, where this is the only one solution. So one solution. Okay, and that's for 5 marks. So I hope that was helpful. I think that was a pretty good paper. A lot of 5 marks for sure, but good 5 marks as well that tested you on quite a lot of different things. So I hope that was helpful and you've gained quite a bit out of that video. And I'll see you on the next one. Thank you for watching. Bye.